Pre-AP, pre-calculus, looking at 11.1 homework, talking about periodic functions. Given below are sections of two periodic functions, f and g, watch your language. Use the graphs to answer the questions that follows. The graph of f. We got 4 questions. Find each of the following function values using the graphs of the periodic functions pictured. Show your work. So in order to predict these things, we have to know what the period length is, first of all. So I'm going to trace over one cycle of this graph. And if I took that cycle and repeated it, I would get this graph infinitely. This period length is going from 0, 1, 2, 3, 4. So the period for this is 4. So for number 1, f of 21, that is the same as saying 5 periods of 4 plus 1. Let me say this again. Let me rewrite this. 4 complete periods 5 times. Potato, potato. I'm going to write it this way, though. So this 4 complete period, or 5 complete periods, that doesn't change the graph at all because it's repeating itself. This is going to be equivalent to us just doing f of 1. And at 1, the y value is 2. So this is simply going to be 2. F of 30, well, since each period length is 4, we could fit 7 complete periods in this. 7 times 4 is 28. And then to get to 30, we have to add 2 more. This is equivalent to saying f of 2, because 7 complete periods put you in the same position that you were in, the same height. F of 2 looks like that is a negative 2. F of negative 25, well, we could think of this as f of negative 28, because that would be negative 7 periods. And then if we add 3 to that, that gets us to negative 25. Means this is the same as f of 3. Looking at my graph, here's 3. That has a y value of negative 3. Now when you show your work, you can do it this way or you can do it this way. You can write the period length times the number of cycles that you're doing. Or you can just say, well, this is a multiple of the period length. Either way. For G, if I were to do 1 period of this, it would look like this. That is 1 cycle, and its length is 1, 2, 3, 4, 5, 6, 7, 8. So when I'm doing these problems down here, I need to have multiples of 8 and then add on any or subtract any extra numbers to get me to the number that's listed here. Well, G of negative 64, that's the same as G of 0. And the reason that's the same, negative 64, that is just going to the left a complete cycle 8 times. So it's going to get me back to the beginning, and that has a y value of 1, 2, 3, 4. Negative style. If you prefer, instead of saying G of 0, you could say G of the period length is 8. We're doing it 8 times, and then we're going to add 0 to that because it already gets us to negative 64. This is optional. G of 84. Well, G of 84 would be the same as G of 80 plus 4. What is G of 80? Well, that is 10 cycles of period length 8. This is equivalent to us just figuring out what G of 4 is. If I look at my graph, 1, 2, 3, here's G of 4. If I go up, 1, 2, 3, it has a height of 3, so that's the same as 3. G of 34, let's see, I could do thinking of multiples of 8. 32 plus 2. 32 represents 4 complete cycles with a period length of 8. 4 times 8 is 32. And then there's 2 left over to get to 34. This is equivalent to G of 2. G of 2, 1, 2, 3, 4, 5. That would be 5 in height. Number 7, explain how you use the period of g of x to find the function values in problems 1 through 6. This is a poor question because I only use the period for g of x for problems 4 through 6. So let me change this to 4. Hopefully your notes or your homework will change in the future to reflect that. Well, let's see. I'm just going to put into words what I just did up here. I used the period length times the number of cycles to get a number. I don't want to say close to, within one cycle let's see, how do I want to say this? Between one cycle of this first cycle that I had traced over. So I would say between one cycle from 0 to 8. I use the period length times the number of cycles to get a number within one cycle from 0 to 8. Instead of one cycle, I should probably say within the first cycle. From 0 to 8. And then added a number to complete the number given. This is horribly written. If you were to read this in a vacuum, you would have no idea what's happening. Hopefully, when we were doing the problems, it made sense. And I should have given more thought to this problem before I jumped into the homework explanation. Moving on. Create a table of values representing 5 points that can consecutively be connected by line segments to create one cycle of the periodic function whose period is 7. Explain your table of values can represent a periodic function. All right. So for this is completely separate from question 7. I'm going to make a table. I need 5 points. So let me do 1, 2, 3, 4, 5. Let me change this a little bit. So I have 6 windows here. 1, 2, 3, 4, 5, 6. And that's because for this first one, I'm going to say we got x, and here we got f of x. So I need 5 points. I got 5 horizontal spaces here. And I want the period to be 7. So that means wherever I start, I want to end 7 units later. So I'm just going to go 0 to 7 because that's super easy. And then I'm going to pick numbers between 0 and 7. These don't have to be equally spaced. So let's say 1, 3, and 6. Doesn't matter what I choose. This first number and this last number have to be the same. So let's say that I choose 8 for those. These numbers in between can be whatever you want them to be, essentially. Let's say that I choose 0, 2, and 4. Explain why your table of values can represent a periodic function. Well, first of all, I need a period length of 7. So the same y values are used here, and those are 7 units apart. And since this is represented by segments, which is what it says to do, when I connect these points and I were to draw this out, it would be a periodic function. Terrible explanation. Let me retry that again. Since the beginning and end of my cycle have the same y value, I could be repeating this and it could be a periodic function. I won't ask you to do that on a test, I don't think. 9, create a table of that. I might ask you to make the table, but the explanation, that's pretty difficult to do. Create a table of values representing 5 points that cannot consecutively be connected by line segments to create one cycle of a periodic function. Explain why your table of values cannot represent a periodic function. All right, so let me draw a table. Let me use the same table, I'll change values. So if these can't be consecutively connected by line segments, but I do need points. Well, what I was going to do initially here is say that one of these is undefined, and I couldn't connect them. I'm trying to figure out how I can make a table of values, but when it says that cannot consecutively be connected by line segments. Oh, all right. This might be a no-duh here. What if I were to make a parabola? That is clearly not connected by line segments, and that also clearly would not be a periodic function. So for example, let's say I start here at 0, the y value is 0, 1 squared is 1, negative 1 squared is 1, 2 squared is 4, negative 2 squared is 4. Well, this is interesting because if you look at this table just by itself, this could be a periodic function. But when it says that the points cannot be connected consecutively to connect line segments, let me just be a little bit more specific here, and let's just say this is x squared. I don't love this question. Explain why your table cannot be a periodic function. Well, if I'm saying it's y equals x squared, it clearly can't be because it doesn't repeat itself. Just looking at these numbers, it sure could look like this could be. I'm going to move on from 9 and leave this as a, I wish I would have not asked that question or given it more thought before I jumped into the homework. 10, use your table of values from 8. State your domain, range, and amplitude. Let me just grab this real quick. So what is my domain? Well, if this little guy's going on forever and there are no discontinuities, the domain is going to be all real numbers. What's the range for this fella going to be? Well, it goes as low as 0 and as high as 8. So the range goes 0 to 8 inclusive. What's the amplitude? Well, the amplitude would be halfway, the distance that is half the distance between your range. So 0 to 8, halfway between that would be 4. That's the amplitude. Good enough. 11, sketch a graph of 2 complete cycles of your function from number 8. This is terrible because I chose numbers that are outside of this, but oh well, I'll work with it. So I got 0, 8. Let me measure this distance here. So 0, 8 we'll say is here. And then we got 1, 0. And then we got 3, 2. And then I got 6, 4. And then I have 7, 8. Originally, this said that each of these were connected with segments. So I'm just going to connect those segments. We want 2 complete cycles. Well, there's 1 right there. So since this has a period of 7, I'm going to move 7 units to the left and right of each of these points. Well, just to the left. So if I take 1, 0 and go to the left 7, I'm going to be here. If I take 3, 2 and go to the left 7, I'm going to be here. If I take 6, 4 and go to the left 7, I'm going to be here. If I take 0, 8 and go to the left 7, I'll be at negative 7, 8. So that's going to give me 2 cycles of this first one that I drew and then this other one that I drew. Could have copied it and pasted it, but I just tried to show you the process that you would go through there. Notice once again, each of these distances is 7 between corresponding points because the period's 7. All right, that finishes it up. Sorry about number 9.